Good evening, or in fact, good night. It's now pitch black outside. I'm gesturing that way because the windows are over there. We've got lights blazing inside so that we can make a video, though the camera thinks that we're underexposed, as usual. We can fix that in post. What we're really here for, though, not talking about camera work tonight, though I might do a video about that, but what we're really here for is this. This is the motor housing from the Meddings tool grinder, a motor housing motor spindle. And hopefully, by the end of the video, we'll be getting this powered up. I say hopefully, because you don't know, or I don't know how things are going to go. I don't know what condition this is in. And what we're not going to do is plug this in straight away. We want to take this apart, have a look at the assembly, make sure there's nothing in there that's going to rattle around, it's going to cause any damage, if there's any corrosion, if the bearings are shot. They certainly sound a bit dry. You hear that. They don't sound great, do they? So, in order to make sure that we're not going to do any damage to the motor, or the motor isn't already damaged and we're going to turn it on, short it out or something, we're going to take all of this apart. We're going to start the disassembly with the guards here. So this is formed of two shells. There's an inner shell and an outer shell. There's one here and one here. And I thought, I may still be right, but I thought initially that this shell screws onto this one. Essentially you have a couple of screws that keep it in place, a couple of set screws or thumb screws or whatever, because there's a boss here. If I spin this over, there's a boss there as well, and they're both threaded. So I sort of assumed that this was supposed to spin on here and not the whole thing. We'll really find out when we get it apart. So I did already take apart the other end a while back so I could check the size of the wheel. We were doing a ARW, not like podcast, but discussion thing with a few of us, and we're talking about braces. So I took this off to borrow the wheel. I noticed that somebody had cut this down. So I'm holding this now with the two backs coplanar, and you can see, well, hopefully you can see, if I bring this up here, the size difference. And I know it's been cut down because, oh, look at those bosses, they're in half. So somebody's trimmed that down. I'm fairly certain that that's not from the factory. I can't imagine why someone would do that, but I suppose people have their reasons. If they were accommodating a thinner wheel, maybe a wheel that doesn't have as much depth as this one, and they thought, well, I'll just cut the guard down. But it doesn't make a lot of sense to me. I think you'd surely if you've got a workshop capable of doing that, you cut off a spacer, don't you? Well, anyway, we'll find out. So I have doused this thing with WD-40. I'm going to chuck a little bit more on there, because the other one was somewhat reluctant to move. Everything is rusted on this machine, so it all requires either a blowtorch or a hammer or both. So on this occasion, it's the hammer. I really need to get a little a miniature Mjolnir. I think that'd be awesome, wouldn't it? So I've got a tyre lever, fairly well worn tyre lever, and we're just going to knock this off gently. If we do, we'll probably give it a bit of a ding, but what we'll do then is when we come to refitting everything, we'll just make sure it's all cleaned up and there aren't any sharp edges or anything like that. So we're going to knock this off gently, and that was far easier than I expected. I didn't think that was going to come off like that. Well, we'll try it by hand actually. Oh, perfect. So what's going to happen now, we'll knock that and it's going to fly off, isn't it? Ah, there we go. That's our guard taken off. And now we can get to the wheel. Now we can access these screws here. Looking at this one, I have no idea what's going on there. That's got a nice big dent in it. So yeah, we're going to remove these. Get these out of the wheel. So hopefully, ooh, there we go. Right, I did think these were going to be tough. I should have soaked these in oil. Really, I don't know if we have. I mean, you see the American guys, and they're all like, they got all different oils, different things, and to be honest, over here we sort of don't really bother. You got WD-40 or 3-in-1 or. Alright, you have your whey oil and stuff for your machines, but I mean, for odds and ends like this, WD-40. It gets in there and loosens stuff up, right? I can't think of a sort of specialist thing for that. Not locally, anyway. Anyway, I'm waffling on. Right, hopefully this one's not going to be in trouble. There we go. But I still wonder why there were only 3 screws in there. That's a mystery we'll solve when we get everything apart. He's going to get some bags for the screws as well, actually. So hopefully our wheel will just pop off. But no. So is that bolted on through the hub here? I don't know. Really don't. The other one just came off. It didn't need that. Yeah, looking at the other one, this hub here just popped off. Let's give that a squirt, and I don't really want to give it a tap with a mallet because it's a spindle, isn't it? So maybe I don't want to overdo it, but to give it a bit of encouragement might loosen it up. Okay, so that seems to have done the trick. Let's get it moving now. There we go. And that is a fairly, well, there's the I'll put it down for a second. There's the I guess the wheel boss, whatever you want to call that. It's the hub. And this is a fairly chunky, and it looks like a diamond wheel, so a very chunky diamond wheel. Look at the thickness of that. And all of this will be aluminium, and it will just be the material here. In fact, it might not even be all that. It might not be a lot left on there. Looking at it. I hope I'm wrong. I hope there's loads left on there, because that would save me a fortune. These wheels are not cheap, but then they last for years, so there's that. I'm having to go back to the other side and check what comes off and what doesn't. So now I think we need to take off the try taking these nuts off here. I grabbed a ratchet that fits. These are 70mm bolts. A hole on the other end. And give it a turn. Actually, do you know what? We'll do the there's a lock nut and a nut on there, so we'll do them one at a time. Oh, that one's freed up nicely. Oh, there you go. Right, so that's off of there. Should this come free? I mean, it looks like there's a washer there. Try and give that a nudge with a screwdriver. Yeah, that's a washer. It doesn't look like there's anything behind that, so I wonder if now this should be free to move off of that spindle. Okay, I figured it out, and this did take a bit of brute force. It was a matter of just whacking the tyre lever in there and going round and knocking it off the shaft. And this is really cool. It's very exciting. And don't want to sound this back on here for reasons that will become clear in a second. So first things first, I figured out why there are only 3 screws. 1, 2, 3, and number 4 is partially occupied. So someone's been too lazy to remove that, or buy a replacement part, or you know, whatever the case may be. Even I think this is aluminium, so it should be fairly easy to turn a new one if we really need to. If I can't get that out and yeah, rethread it. So yeah, this is cool. It's exciting because, well, firstly, it sits on a taper here. The spindle shaft is tapered, which is really neat for a tool grinder. But check this out. See that? So the balance weights, see how they're wedged in? That's cool, isn't it? They're just screwed in. I'm assuming they're for balance. That's really neat. Little discoveries like that really, you know, kind of make my day, or my evening in this case. Now that we've done that, we can get to these 4 screws, and hopefully that'll be. I mean, these have been fairly protected from the elements and corrosion and whatnot. They don't look like they're particularly rusty or anything like that. So I'm hoping they're going to be fairly free to unscrew. That's 1. Oh, they're fairly short. Nice little, yeah, nice little screws. I mean, I have to admit, I think like a lot of people, I'm not a big fan of slotted screws. We'll probably put these ones back in because they're not in bad condition, but there is definitely a temptation. Well, and because I'm trying to keep it, you know, fairly faithful to the original, how it was built originally. But there is a temptation to replace those with socket caps. But we're not going to do that. We'll keep those because they're in good nick. Now, hopefully, keeps lots of hopefully this will come out really easily, right? So how's this? So I'm wondering how this is held in. Is this held in by this plate here? And I'm just going to have to wiggle it, and yes, it is. Yes, it is. And that's that. So yeah, that plate sits on there, holds this. I'm still not clear. Still not clear on whether this is supposed to stay still or not. Yeah, I don't know. I really don't. And there we have, oh, there's locating pins. There's 1, 2 locating pins, and those are sprung. And there's a third which has just sprung out. Okay, so we're gonna have to be really careful here. I'm kind of loading everything at the top here. I'm gonna have to get some little resealable bags, but I think we should probably take those springs out. I've grabbed a pick. It's the only one I've got left. It's probably not quite the right one for the job. It'll do. Yeah, there's our little spring. I can't see whether this is focusing or not because the monitor is being overpowered by the lights. There we go. So there's a little spring there. There's one in each of those. Yeah, they're a little rusty. They're not too bad. That's number 3. I'll go and put those out the way. Okay, so again it comes to, is it this part next or this part? I think it's got to be that one, isn't it? I think that must sit on this plate here, and this has got to be the plate that holds the bearings on. Holds the bearings in position. So here's that, hoping that, again, these aren't too, and they're not, I mean, they come loose fairly straightforwardly. Oh, and they're the same size as the other ones as well. But this at some point has been taken apart. You can see that there's a burr there. So that's at some point it's torqued out and damaged the screw head. I hope that's not going to be a problem for us. And that is going to be a problem for us, isn't it? Well, you know what? We'll get this one out first. It'll be nice and firm, getting that screwdriver's a grip. But it does look like that one's going to be an issue. I really don't want to damage the head on this. I don't want to get to a point where we have to drill this out. There we go. Maybe we'll buy some replacement screws just for things like that. Alright, so we've got that, the screws out. And is this going to be another one where it's just a case of knocking it out? It does look like it sits over this plate. Hopefully I'm right. And we're not going to sort of screw something up or break anything. Don't want to poke that too much. Don't want to damage it. Because replacement parts for these machines, bear in mind, are non-existent. And then it's not an exaggeration. It's not like, you know, they're not as rare as hen's teeth, which, by the way, aren't rare because that's how they get out of the egg. So it's not really a tooth. But, yeah, this isn't like, these aren't hen's teeth. These are impossible. Like, they just don't, you know, the parts don't exist. Alright, if we can't get this out, maybe we should just try having a go at the whole plate. Maybe the whole thing will just pop off. So that does look like a seal for the spindle, so I guess that's guarding the motor against having, well, not only coolant actually, but also bearing in mind this is grinding metal, so guarding against getting chips in there as well. So let's get these out. Don't worry, I'm not going to make you sit through all the other side, it's the same by the looks of it. I'll do that one on my own. Okay, so let's see if this moves at all. Maybe, maybe. I know what I just said about the ingress of coolant and whatnot, but oh yeah, if I give that a tap, looks like something's moving. And you want to be careful with things like this. You don't want to go taking your lump hammer and giving it a good whack. You just want to be, it is just a tap to see if the thing moves or not. Though again, I think this might be a flick the camera off and go back to it job, because yeah, I think we have to get something in there and sort of wedge this off perhaps. Okay, so this is starting to move now. So I think we do have to remove this and then we'll get to this one. Though, giving this a tap, and I do mean a tap, so when you can't just go whacking things with hammers. I mean, well, you can if you don't want your machine to go back together, but I do mean give it a tap, and what you'll see is things like around the edge. If you spray it with a bit of WD-40, a bit of oil, you'll see suddenly it'll start to move in and out. It's getting behind the plate, which is obviously what the manufacturers intended this to stop, but yeah, the point is then you know it's kind of moving a little bit. It doesn't necessarily mean that that's supposed to move, but yeah, what you don't want to do is really sort of really go swinging your hammer. There we go. Right, that's starting to ease off now. It looks like it's bringing that seal with it, so it should get easier as it comes along, because I'm assuming that taper is going to end up in a parallel shaft rather than a tapered shaft. Assumptions and all that, you know. I should now be able to remove that by hand. And there we go, we can see the bearing now. And that bearing looks bone dry. And it feels bone dry. There's no, looks like there's any play in it, but yeah, it's not good, Nick. Anyway, there's our seal. That's all there is to it. I wonder what condition this seal was in. It looks good. It doesn't look like it's damaged or galled or anything. There's even still some grease left on there still, but unlike the bearings. So we'll see how we go. You can see actually in the end of this shaft here, that's the centre mark from it being turned. And so I wonder if the next thing to do should be to remove this circlip. And if we do that, can we then having repeated this process on the other side, then tap that shaft through. There's only one way to find out. One thing that you do need to do if you haven't already is go and get yourself a decent set of circlip pliers. This is not a decent set of circlip pliers, but it is versatile because you can change out the prongs here for different sizes and shapes, and hopefully this will make short work of our circlip. That's not always the case though. I mean, they do work pretty well, but oh, there we go. So the fact that it's on a taper means we can pretty much let go as soon as we popped it off. And there's a circlip. And I'm wondering, is that a washer? It is a washer. And so, having done that, I think what we'll do is take all the hardware off the other side and see where we're at. Well, it's a new day. I did come down here earlier to take all the gubbins off of here, off of this end that we took off the other end last night. And I struggled with the wheel hub. Now, yesterday this just sort of popped off. We've got a lever on it and just popped it out, but it wasn't having it. I went down the road, bought a set of gear pullers. I couldn't get them in behind here in the end, and it should have been the first thing I did. I grabbed the blowtorch because obviously this is aluminium, heats up and expands in no time, and off it popped, exposing the shaft seal that we took off yesterday and the bearing. And the bearings on these are actually two different sizes, you can see here. Same ID and OD, but they're slightly different lengths, and you can tell that by the where the bearing sits on the shaft is actually wider. Anyway, once I'd done that, I got these 4 bolts out, well, 3 bolts and a screw. There's a slotted machine screw down here. And the plates at either end opened up, and I'd been trying to leave the bloody things off. That hadn't worked. And the plate suddenly opened up enough that I could get a gear puller behind here and actually pop the whole lot off, separating the bearing and that from the shaft. And actually the bearings were easy to pop out the plate, because I had a bar. I don't know what I'd turned this for, but that fits in the ID really quite nicely, and that fits through the hole, the clearance hole there, just to knock them out. So there's a good bit of luck there. So now all that's out the way, we can have a look at what's inside here, and odds are this is not going to come off now. So I've got my trusty tire lever. We'll just pop this out. There we go. When we reassemble this, we'll use some assembly grease or something like that. So there's the plate. You can see that's where the bearing sits in there. These are, it's quite a deep housing for the bearing. It's just sort of rough cast behind there. It still leaves me in 2 minds as to the paint job for the machine, but we'll probably get onto that later. So yeah, pop this down somewhere and we can take the rotor out. I did put the rotor back in there just so you could see how it all went together. It's fairly obvious that the rotor goes through the stator, right? And there's our rotor. You can see both ends. If I get this in shot, you can see both ends are pretty similar. They both have a taper, and you can see where the bearings sit. You can see the fat bearing goes at this end and the thin one goes at this end. It's a fairly heavy rotor, this, as you might expect from that kind of machine. And there you can see the stator. There's not all that much to look at. It's a load of copper wire, and these are the cables that go unrestrained. Instantly, these cables go to the switch, and there's nothing keeping them out of the way of the rotor. So that's something we might have to have a look at later on when we come to actually wire this thing up. But for now I need to decide whether I'm going to re-grease these bearings or whether I'm going to bin them and buy new ones. I might just price them up and make a decision based on that. So we'll either be back to this in a couple of hours time or back to this in a couple of days time. I'll let you know. I've laid everything out on a bit of board here, the guards, the bearing seals, bearings, end caps and the spindle. And it's more or less symmetrical, apart from, as I pointed out earlier, the bearings, which are different sizes, and the end caps. When I removed these 2 plates from the spindle housing, I said, it turns out incorrectly, that they are the same, and they're not. Now all the mounting holes, clearance holes are all in the same place, the features are all in the same place. However, they are not identical. I don't know if you can see it on camera, but this clearance hole here is smaller than this one, and that corresponds to the 2 shoulders either side of the spindle. I found this out when I went to reassemble this for testing, and you'll see that part of the video in a little bit. Obviously that happened after I got this right. So when I came to reassemble this for testing, I was cranking down and I thought that the pressure I could feel was the bearings reseating on the shaft here. The bearings can be tight. As it turns out, it wasn't. It was this shoulder trying to force its way through this clearance hole, which obviously wasn't going to work, and ended up blowing out this part of the plate. This is where one of the mounting screws sits. You can see that's now just a plain hole, not accountable. Luckily enough, this is not for a customer, this is for me, so I can fix this at my leisure. Otherwise I would be scrambling to get a new bit of cast iron and get one of these machined up on the lathe. I might actually still do that. Then again, I may see if I can get this welded. Either way, it's going to have to be fixed in some manner. Ordinarily, I would have my notebook out and I would be making a sectional drawing of the spindle, where the features are, well, you know, whatever part I'm working on, but in this case a spindle, where the features are, shoulders, diameters, lengths. You have things like the groove for the circlip, the taper, you know, the lengths of the threaded portions of the shaft, where the parts fit together. So I would have things like the clearance holes, you know, where I'd expect to see things. Now, the other evening I was in a hurry to finish up that section of the video, and so what did I do? I didn't make any notes, and I did make notes, but much later on. And by that time, I had it cemented in my head that these were the same. I didn't think to check it, and that's, you know, really a bit of a cautionary tale. In the end, I decided to keep the original bearings as they are. Well, for the moment at least, I can still change them out, and probably will change them out for sealed bearings once we come to redecorate this. You know, once it all gets taken apart for repainting, which will be fairly shortly. But for the moment, they've been put back in here with the spindle, caps, seals, the whole lot. It's all gone back in there, so that we can test our motor. So we want to make sure this thing runs before we do any more work on it, and there is a lot of work to do. There's going to be so much electrical work to do on this machine. But once it's up and running, it's going to be really, you know, really very beautiful a bit of kit. So to test the motor, I've got this fairly sizable step-up transformer. This does 230 to 400 volts, but also 230 down to 24 volts. That's going to help with things like the control voltages for relays and contactors that we're going to need. It will do our, you know, all of our switches will be at control voltage. They won't be at line voltage, which is good. And I was given this by a friend of mine over on Instagram. He doesn't have a YouTube channel as far as I'm aware. He's got an Instagram account, so I'll link to that in the description. That's Swansea Road Bikes. We'd been talking for a while about 3-phase conversion, and he'd ordered 3 of these, obviously one for each phase. 2 of them were knackered in transport. So he said, "Do you want the other one? You know, give me the postage and I'll send it over to you." And it's very nice thing for him to do. And it's been a big help in getting this machine up and running. We also have this dinky little capacitor here. This is a 18 microfarad cap, and this essentially emulates the 3rd phase to the 3rd leg of the motor. The motor itself is a dial-under motor. That means it's speed selectable, so it's between 1500 and 3000 RPM. It's a really interesting, electrically it's an interesting mechanism by which it does this, and we'll look at that in the, well, when we come to rewire the machine. And we'll also go over how this capacitor here works. So I'm really careful not to touch these things, you know, I've got exposed contacts and whatnot, even though I've got the plug, I've got the plug right here. I don't trust myself not to give myself a shock. So, yeah, I still treat it as if it's all live. That's fairly good practice. But I am excited to explain to you how these things actually work, but it's just going to extend this video, and really all we care about right now is whether this motor does in fact run. So, the only thing left to do really is to plug it in and see what happens. And for that I'm going to wander over to the socket in the wall. And this is the nice thing about doing it this way, is that I can't touch anything that's live while it's energized. So pop over here, flick the switch, I'd say it's a fairly successful test. Now, while on the one hand I'm glad that this is running, that's great, there is more work to do. Like I said, because it's a 2-speed motor, that depends on the configuration of these 3 cables and these 3 cables here. I haven't quite figured out, well, I've tried a couple of different wiring configurations. I don't really know what the hell's going on. I can get it to change speed, but I don't really know why. You know, I know sort of theoretically why it should work. But anyway, I think that's probably enough for this video. I think we've probably gone on enough. And yeah, you know, if you're carrying on along watching this with me, that's really cool of you. And yeah, I'll see you in the next video.